Hello dear students and welcome to our online class. Hope that everybody is doing fine in their own home and safe. This is your teacher, Sir Andrew Matula, and let's learn together arcs and inscribed angles for Mathematics 10. So today, we will explore and understand all about inscribed angles of a circle. At the end of this lesson, you should be able to 1. Identify inscribed angles and its intercepted arcs. 2. You should be able to solve the measure of an inscribed angle and its intercepted arc. And lastly, find the measure of an inscribed angle given the measure of a central angle. Okay, before we go to our main lesson, let us first backtrack to what we have learned about the central angle and its intercepted arc. In this activity, you are going to find the measure of the inscribed angle or its intercepted arc shown in each figure. For the first figure, what is the measure of the central angle? If you answer 120 degrees, you are right. Remember the theorem of central angle? The measure of its angle is equal to the measure of its intercepted arc. How about this next figure? What is its intercepted arc? Correct. The answer is 123 degrees. Great that you all understood about the central angle and its intercepted arc. Let's go now to our main lesson. I want you to look at the figure. What do you think? Are the angles in the triangle congruent? When we say congruent, they have the same 3 sides and exactly the same 3 angles. So yes, we can say that those angles are congruent. What is the measure of the arc intercepted by each angle? Remember that the angles of the triangle are congruent and that the sum of the angles is equal to 180 degrees. So each angle is measured 60 degrees. And if the measure of each angle are equal, so does its intercepted arc. And remember also that the measure of the circumference of a circle is 360 degrees. So each intercepted arc of the angles must be equivalent to 120 degrees. Can you name the angles shown in the figure? If your answer is angle CBD, angle CBB, and angle BCD, your answers are correct. And these angles are what we call inscribed angles. So what is an inscribed angle? This is an angle whose vertex lies on the circle and whose sides contains the chords of the circle. Remember the chord of a circle? This is the line segment whose endpoints touches on the circle. In this figure, we can read the inscribed angles as angle CAB or angle BAC. Let's go now to the intercepted arc. The intercepted arc is the arc that lies in the interior of the inscribed angle and its endpoints on the circle. Just like what is shown in the figure, the arc is formed that connects the 2 endpoints of the angle, point B and point C. And we read this intercepted arc as arc BC or arc CB. To further understand this concept of inscribed angles and its intercepted arcs, let's take this example. Now let us identify the inscribed angles and the arc intercepted by each angle shown in the figure. Take a moment and look for the inscribed angles. How many did you find? If you say 4, you got it. What are those angles? Angle CAB, angle ACB, and angle ABB. That's correct because its vertex lies on the circle and whose endpoints lies also on the circle. Very good. How about its intercepted arc? How many did you find? There are only 2 intercepted arcs, and that is arc CD and arc AB. For angle CAB and angle CBD, its intercepted arc is arc CD. And angle ACB and angle ADB, its intercepted arc is arc AB. Did we get the idea now what and how we can identify an inscribed angle and its intercepted arc? This time, let us understand how we can find the measure of the inscribed angle and the intercepted arc of that angle. To measure the inscribed angle is equal to 1/2 of the measure of its intercepted arc. And it means if you are given a value arc AC, half of that value is the measure of its inscribed angle. To find the measure of the intercepted arc, it is twice the measure of the value of the inscribed angle. For this example, we are going to find the measure of angle ACB. And by looking at the figure, arc AC already have a value of 124 degrees. So to find the measure of angle ACB, it should be 1/2 of arc AB. So we substitute arc AB with its value, that is 124 degrees. To solve, we multiply 1 with 124 divided by 2. Therefore, our inscribed angle ACB is equal to 62 degrees. And by looking at it, 62 is half of 124. Let's do another example. This time, we are going to find the measure of arc XY. Given is the angle XZY with a value of 70 degrees. So remember that in order for us to find its intercepted arc, it is twice the measure of its inscribed angle. So we substitute angle XZY with its value of 70 degrees. So we multiply 2 and 70, so our arc XY has the measure of 140 degrees. And 140 is twice the value of its inscribed angle. This time, let's check if you understood everything we had discussed on inscribed angle and its intercepted arc. Identify what is asked in each figure. What is the measure of angle CAB? That is correct, 40 degrees. How about this one? What is the measure of arc WV? If you answer 84 degrees, good job. See, that's how easy, right? Let's level up. How about this one? What is the measure of arc DC? If you answer 122 degrees, you are absolutely correct. How did you find the answer? We don't have the value of the inscribed angle. Do you remember? The sum of the angles of a triangle is 180 degrees. And in the figure, we are given the values of the other two angles. So therefore, we can solve the unknown angle. Just add sub 49 and 70. Then subtract the value to 180, which is 61. And 61 is the value of the inscribed angle of arc DC. So we double 61, that is why our intercepted arc is 122 degrees. Good job, everybody, and hope everybody is catching up. This time, I want you to go to your module and answer the given activity to you in What's More. If you encounter some problem, you can always go back to this video and relearn until you get it. Until next time, this is your teacher, Sir Andrew Matula, and see you in our next lesson. Keep safe, everyone!